Hi there folks, I was just given an email here to ask to do this question here. So it starts off and it says graph these two functions here. Now this is the modulus here, and what that means basically is when x plus 3 is less than or equal to 0, the number is going to be positive. So if x is minus 4 plus 3 is minus 1, that has to be graphed as 1. So to graph that as follows, you do this. So you draw your graph here like this. And we pick points like this. So that would be when x equals 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. Okay, so when x is equal to 4, we do 1, 2, 3, 4, 5, 6, 7. So when x is equal to 4, 4 plus 3 is 7. When x is equal to 3, it's 3 plus 3 is 6. Make that a bit smaller. That 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. Now minus 1 plus 3 is 2. Minus 2 is minus 1. Minus 3 plus 3 is 0. Now minus 4 plus 3 is minus 1. Because it's the modulus, you're going to write it as 1. And so on. So you'd work your way back up. Like that. So then to draw that, you just do this. Down as far as there. And then all the way up here like that. Okay? So that's that drawn there. Now, gx is equal to 4. So for gx equal to 4, you go to 4, and draw your line across. Okay? Now, you're asked then to find, using by writing the solution set to the inequality where fx is less than gx. Okay? So fx is less than gx as follows. So if I drew a graph down to here, fx, gx. So they're equal at 1 and minus 7. But from between 1 and minus 7, fx is lower than it. Its value is less than gx. So what you could say there for that second part there, so part 2 of this question, so fx is less than or equal to g of x when x is greater or equal to minus 7, less than or equal to 1. So how do you prove that algebraically? Well, the way you prove that algebraically is you create an equation. So you do as follows, x plus 3 is less than or equal to 4. And you square both sides. So x squared plus 6x plus 9 is less than or equal to 16. Bring the 16 over, x squared plus 16 minus 7 is less than or equal to 0. And you solve x plus 7 times x minus 1. So you let them equal to 0, so you'd say x is equal to minus 7 or x is equal to minus 1. So that's where you know where they're equal. So it's going to be between these two here. So therefore, x is greater or equal to minus 7, less than or equal to minus 1. Because you take a value, say, bigger than that. So say you take 0. And if I put 0 in here, okay, now you're getting minus 7. Oh, sorry, yeah, so it's less than 1. So if I take x is plus 1, sorry. So if I take 2, I'll put 2 in here. 4 plus 24 is 28, minus 7 is 21, which isn't less than 0. So therefore it falls outside that parameter. Whereas if I took a value between these two here, so say 0, because 0 falls between minus 7 and 1, you get minus 7, so it's less than 0. So that's how you do that algebraically. Okay? So that was the answer to that first part of the question there. Okay? Now, the next one here is as follows. So we're just going to move on to a new page, and let me just copy this here. Now we'll just copy this and we'll start a new question here now. Okay, so the cubic equation, x cubed minus 7x squared plus 17x minus 15 is equal to 0. Now, it's one integer root and two non-real roots. Now, there's a bit of a there's a little cheat here to do this, right? You have to do trial and error. But in an exam situation, you don't have time to be putting all the numbers in. So what you do is you go and you type in, you do mode table. And you type in x to the power 3 minus 7x squared plus 17x minus 15. You let it equal to 0. You start, say, minus 3, go up as far as 3, go up in steps of 1, and you look at your table, you find out where you get 0. And you get 0 when x is equal to 3. So we know x is equal to 3 is a solution. So therefore, x minus 3 will divide into this here. So that's a trial and error as part of the factor theorem. Okay? That's something I'm going to be looking at next week in the honours class. So I've got x cubed minus 7x squared plus 17x minus 15. So divide it in then. I got x squared, which gets me x cubed minus 3x squared. I subtract that. That's going to get me minus 4x squared. And I bring down my 17x. So this is long division. So then you multiply that by 4 minus 4x. So it's minus 4x squared plus 12x. Now, it's funny this because this came up in the mock and it's actually something I'm going to be looking at next week. So it just shows that the stuff that we will be doing comes up on the exam. Minus 15. Now, x into 5x goes 5 times, and 5 times minus 3 is minus 15. Now, the next part of this question is to do with complex numbers. So what happens here is, if you look, we've got x squared minus 4x plus 5, right? Now, if you were to do the minus b formula with that there, so if you want to check that in there, you can always just pause the video. It's very handy to take that down, or if you're not sure on it. Okay? Now, so what I'm going to do here is a is equal to 1, b is equal to minus 4, and c is equal to 5. So it's going to be 4 plus or minus the square root b squared, which is 16, minus 4 times 5, 4ac, 4 times 5, which is 20, all over 2. So that gets me 4 plus or minus the square root of minus 2. Minus 4, sorry, all over 2. Now, can't get the square root of a minus number, because any minus number is going to give you a positive. So there's no such thing as a square root of a negative number. So that's why we use complex numbers. The square root of 4 is 2, and we write imaginary number, 2i. Divide that by 2, and we get 2 plus or minus I. So therefore, our three roots are going to be, the three roots of the equation are x minus 3, 2 plus I, and 2 minus I. That's how you do that question there. Okay, so again, hope that's okay. If you have any questions, you guys can send me an email. Thanks, guys.